So in the SQL materials we covered in the last week, we can write some basic select from where statements. And these statements generally they are operating based on some relations or tables. However, sometimes we may have some cases and we have to run the select from where clauses or statements based on the intermediate result we get from some other statements. If so, then we need to introduce another very important concept. It's called subquery. So forming a parenthesis-sized select from where statement, the subquery, can be used as a value in a number of places, including both the from and the where clause. What does this mean? Before we mentioned that in the from and the where clauses, for the from we need to work on some relations, right? For the where clause we need to work on some conditions. And they are also based on the relation, right, in the from clause. If we want to run a select from where statements based on an intermediate result from another statement, if so, then we can use this intermediate result as a subquery. And they can also be used in some other select from where statements. So we can also provide you with some examples. Now, in the place of a relation in the from clause, we can place another query and then query its result. To use this query as an intermediate result, we can also use a tuple variable to name tuples of the results. And sometimes the subquery we get, the result, can actually be scalars. Normally we mention that for select from where statements, the result will be a relation, will be a table, right? However, sometimes if we can guarantee the subquery can produce one single tuple with one single attribute, then the subquery can be used as a value, right? So what does this mean? Before we mentioned that the select from where these statements, they will return a table, right? They will return a table, something like this, right? We can get a table. Inside table we have some desired attributes, right? And this columns denoting the desired attributes 1, 2, 3, right? And the rows denoting the tuples matching the conditions, right? And the rows denoting the tuples matching the condition in the where clause. And sometimes if we have one single desired attribute, in other words, the returning result has one single attribute, and we can delete all the other columns. And at the same time, we can also guarantee that we have only one single row in the returning result. In other words, besides this name of this attribute, we have one single data tuple in the return result, right? It is still a table. However, this table containing one single row and one single column. If so, then we can use this returning table, this tiny table, as a value in some other queries, which is as described here. These subqueries can return scalars. And normally we need to guarantee that the returning result has one single row and one single column. If we can guarantee so, then we can use it as a value or a scalar. This single tuple can often be guaranteed by the key constraints. We can use a key constraint in the conditions to guarantee the returning result can be a value. If you plan to use this subquery as a scalar, please be careful because a running error may occur if there is no tuple or more than one tuple. If in the return result we have multiple tuples, multi-rows, then we cannot use this return result as a value, right? If in the return result we have no rows, no tuples at all, then this table will be empty, right? We cannot use it as a value neither. So please be careful if we use this subquery as a scalar. So this is about subquery, and we'll provide you with an example how to use subquery to help us. And at the same, we have a question from the sales table with bar B and price. Please find the bars that serve the meaner, the B and M, meaner, for the same price as Joe's bar charges for Bart. Before you see the answers, please try to do this query by yourself first. So we have different ways to do this query, right? If you still remember, before we mentioned that we can use the same sales is the table multiple times to do this query. If we use the material relation SQL or the select from where these statements, how we do this question? Okay, so if we do this query with this material relation SQL statements we learned from the last class, we can do the query very easily, right? We can do so by writing down the statements as follows. We select the bar name, right? Because we will use this sales table multiple times, so we can do so by writing down s1.bar from sales s1 and sales s2, right? We use this same table multiple times where what? Well, s1 dot beer equals to mineral, and s2 dot beer equals to what? Equals to Bart, and s1 dot price equals to s2 dot price, and what? And s2 dot bar equals to what? Equals to Joe's bar. And then we have semicolon. So this is the statement we can learn from the last class, right? For using the same sales table multiple times, we also rename it with s1 and s2 as names. So we need to require s1.beer should be the mineral, right? s2.beer should be Bart, and s2 bar should be Joe's bar, right? And they say the beer with the same price. And then we can return the s1.bar, denoting the bars which serve the mineral for the same price as Joe's bar charged for Bart. Okay, so this is the statements we can write down based on what we learned from the last class. You can also want to decide the answer like this. Can we have any other potential answers? The answer is yes. We can also use the SubQuery to help us. So what do I mean? So if we check the question again from the sales table, find the bars that serve the mineral for the same price as Joe's bar charged for Bart. If we want to answer this question, the first one, you may wonder what is the price that Joe's bar charged for Bart, right? If we can have price, then we can use this price as an intermediate result to help us find the bars which serve the mineral with the same price, right? Then it provides us with a hierarchical thinking for writing down queries in SQL. So the first question will be to find the price Joe's bar charges for Bart, right? And the second question will be to find the bars that serve mineral at the same price. If we think in this way, then we have to use this SubQuery to help us. So to find the price that Joe's bar charges for Bart, we can write down the select from where statements as shown at the bottom. We select price from the sales table where bar equals Joe's bar and beer equals to Bart. This statements will return the price that Joe's bar charges for Bart, right? And at the same time, we can also guarantee the return result contains one single column and one single row. In other words, we can use this intermediate result as a scanner. So remember, we have parentheses. This parentheses denoting this statement denoting a subquery, and we use this price equals to parentheses with the select from where statements as in bottom. We are matching the price with the return result from this statement. Then we can do the second question, find the bars that serve the mineral at the same price. So we can do by select bar from sales table where the beer equals to mineral and price equals to the return result of this subquery. So we need to have this parentheses This is denoting the subquery. So this is about the subquery. It can be very helpful for us to work on some very complex queries. And we can simplify this query into multiple subqueries to help us. Also remember, if we use this return result as a scanner, we will make sure it contains one single row and one single column. Then we can use it as a scanner, right? Okay, this is about the example. So besides the previous example, which matches the value versus a returning result of a subquery, in that case, we can guarantee the return result of the subquery is a value, is a scanner, right? However, in most of cases, the subquery will return a table, a relation. And SQL also provides us with lots of keywords or operators to do queries based on the subquery to help us. In this page, we're going to introduce an important operator. It's called in operator. So formally, the in operator can check if the tuple is a member of a relation or not. If we plan to use this in operator, we can use tuple in relation. It's a Boolean statement. It will return true if the tuple belongs to or is a member of this relation. It will return false if it is not the case. Besides in, we can also use this tuple not in a relation, means the other way. And normally we use this in expression in the where clause. And the relation normally can also be a subquery actually. At the bottom, we show you with the example. So we have a question from a beer's table with name, manufacturer, and next table between the drinker and the beer. We want to find the name and the manufacturer of each beer that Fred likes. So before we show the answer, you can also write down a query by yourself if we want to use these two relations to do this question. I think you should be able to write down a query, right, without using a subquery. So we can select the beers dot manufacturer and name, right, from beers likes where the next dot drinker equals to Fred and beers dot name equals next dot beer, right? This is what we can write before we learn the subquery. If we plan to use subquery in this question, how can we do this? So the first sub-question in your mind should be, what is the name of beer that Fred likes? Right? And the second question will be, what is the name and the manufacturer of these beers? So to answer the first sub-question, we can write down a subquery inside the parentheses. We have parentheses, select beer from the likes where drinker equals to Fred. So this subquery will return what? Will return the beer name, right? The beers that Fred likes. However, for this question, we want to find both the name and the manufacturer of these beers. Therefore, we can use this subquery as an intermediate result in our size select from where statements. We can write down select star. I hope you still remember what is the star here. From beers, where name in this subquery. And we have semicolon denoting the end of this query. Here we use this in operator to help us. In operator will check this attribute. Is in the return result of this subquery or not? If so, we will select them and return them. Otherwise, we will just prune them. So this subquery will return a table, right? Inside this table, we have one single attribute, it is the beers. However, we have multiple rows. And this is where in the subquery will check if its name of this beer is in this table or not. The table denoting the intermediate result by subquery. If so, we will return both the name and the manufacturer, because here we use a star here. Okay, so this is the way we can write down this query by using the subquery together with the in operator. It can be very helpful because it can provide us with another way to think about this question. We can do this question in a hierarchical way. And we can do is find the beers for an X, and then further find both the name and the manufacturer information of these beers. Okay, so this is about the in operator. The in operator we showed before can check if a tuple is inside a relation or not. And sometimes we don't want to check this. We just want to check if a return result is empty or not. If it is empty, then we can return false. Otherwise, we can return true, right? So then, if so, then we have to use this exists operator to help us. Format grammar for the exists will be like this. Exists, we have parentheses. Inside, we have a relation. This operator will return true if and only if the relation we're working on is not empty. So this exists is also a Boolean operator. It can be used in a where clause as well. We'll provide you with an example for using this exists operator to help us. So from the beers table with name and manufacturer, please find those beers that are the only beer by their manufacturer. Before we should answer, you can also write down a query by yourself if we don't use SubQuery or the exists operator. So here we can do this question with the SubQuery as well as the exists operator. So if we check the SubQuery first, inside the parentheses, we have a statement select store from beers where manufacturer equals to B1 manufacturer. This B1 denotes a variable. It's a renaming of the beers table, right? B1 denoting the beers B1 here. And this domain for the manufacturer, this manufacturer denoting the beers, this beers. And if we also want to use the manufacturer of the beers, the B1, then we have to use this B1.manufacturer, right? It has a different domain or scope. At the same time, we also need to make sure and the name of this beer not equals to B1.name. So please be careful when we write down the query like this about the scope. The manufacturer refers to the closest nested from with a relation having that attribute. In other words, this manufacturer without this relation name, it denoting the attribute of this beers, this relation, which is the closest to this attribute inside this query. Similar for this name, it is also one attribute in this beers, this relation. So this subquery will return what? We return the beers with the same manufacturer as B1, but they have different names, right? If this subquery is not empty, in other words, given a beer, the B1, right, we can always find a beer with different name produced by the same manufacturer. On the other hand, if this subquery is empty, it means we can never find some other beers with the same manufacturer by different names. This should be the result we want to get, right? Therefore, outside this subquery, we have another name from beers B1 is the renaming of the beers, where not exists. Then we have this subquery as shown here, and we have a semicolon denoting the end of the query. In this way, we can find the beers which are the only beer by their manufacturer. We can never find some other beers from the same manufacturer but with different names. Here we use this not exists to help us. It will check if the subquery is empty or not. So besides this in operator and the exists operator, another important operator we want to introduce here is called any. The any operator. It is also a comparison operator. It compares a tuple versus a relation. It is a Boolean condition, meaning this x equals to at least one tuple in the relation. We can use x equals to any with a relation, right? It means this x equals to at least one tuple in the relation. And this equals can be changed with some other comparison operators. We can use this larger than or no smaller than some other operators. It denoting a comparison between a tuple versus a relation, right? So we provide you with the example like x is no smaller than any of a relation, means x is not smaller than some tuples in the relation. If we can find one case, make this condition holds or legal, then we return true value. Otherwise, we can return a false value. Also, please be careful. We also need to ensure this tuple contains one single column or one single component only, because we're doing a comparison. We need to make sure this x it has one single column. Similar for this relation, it contains one single column, so we can do the comparison, like equals or no smaller than, as shown here. Besides the any, another operator will be, which is very similar, is called the OR operator. This OR operator is very similar to the any, however, it conveys very different semantic meanings. The grammar for this OR operator is very similar. We can use like x not equals true or of a relation. It can return true value if and only if for every tuple t in the relation, x is not equal to t. You can also compare with this any, right? For the any, if we can find one case, maybe this condition holds, it will return true value. However, for the OR, this operator, we need to make sure for all the cases, this comparison doesn't hold, then we can return true value. In other words, the semantic meaning for this x not equals to OR relation, denoting this x is not a member of the relation. And this not equals to this operator can also be replaced some other comparison operators as well. For example, we can use this x is no smaller than all relations. It means there is no tuple larger than x in a relation. I hope you still remember in the homework 2, as well as previous slides, we have one question to find the highest value of a relation, right? I hope you still remember how we do this question before, right? With both relational algebra as well as SQL. Here we can do this question in a much simpler way by using this OR operator to help us. We have a question as shown here. From a sales table with bar beer price, please find beers sold for the highest price in the table. How can we do this question? Before we can do this question by using the sales table twice, right? We can use sales S1, sales S2, and then do some comparisons. However, here we can do it in a much simpler way. When we see a question like this, the first sub-question in our mind will be, what is the highest price appearing in this sales table? Right? What is the highest price? So we can denote the highest price of all the beers in this sales table as we have parentheses, this is a subquery, right? In this parentheses, we have select price from sales. This subquery will return what? We return all the price in the sales table, right? And then we can do a further comparison where price is no smaller than or of the subquery. It denotes what? It denotes this price is no smaller than all the values inside the subquery, right? And these values inside this subquery denoting all the prices in this sales table. So it means this price is no smaller than any price in the sales table. In other words, this price will be the highest price in the sales table, right? Then we can do the select from where statements outside. We have select beer from sales table where price is no smaller than all the price inside the subquery. Okay, in this one we can do this. We can answer this question in a very different way. You can compare its expression versus the one we write before. Right? This one will be easier for you to understand, I think. So this or and operator can be very useful for us to write some queries to help us.